Saxon Math 76, Lesson 101. You are in the right place. Today we are going to talk about an idea that is so simple that you already understand it, so don't let the big word throw you. The big word is proportion. It sounds like something new and difficult, but it's not. Let me show you a proportion that you will understand. Here's what a proportion is. It's a fraction that is equal to another fraction. We've done enough work with fractions, you guys, to understand that fractions can be changed, right? You can multiply top and bottom by the same number, divide top and bottom. When we look at a proportion, it's a true statement about two fractions or ratios. You can call a fraction a ratio. It's kind of weird, but you can. And we look at the relationship between them, and quickly we can see, oh, what we did here is 3 times 2 is 6, and 4 times 2 is 8. So that's the proportion between these two. Again, this can be called a fraction, or it can be called a ratio. Same difference, right? And that's true for there are fractions or ratios. It's the same thing. So let's look at some of the examples. 101.1, okay? It says, which ratio forms a proportion with 2/3? And then it gives us 4 choices. I'm just going to write them down. You don't have to write this all out in your homework. 2/4, 3/4, 4/6, and 3/2. Okay, so to form a proportion, we know that you're either multiplying up or dividing. You can go from bigger to smaller, right? That works also. But there has to be that relationship where the same number is changing the top and the bottom. Okay, so 2/3 and 2/4. No, that doesn't make any sense because the 2 stays the same and then the bottom somehow changes to a 4. So no, that's not going to work. What do we multiply by 2 to get 3? Well, we know that 2/3 are not the same. We can imagine it with a pizza, right? 2/3 of a pizza is not the same as 3/4 of a pizza. Goodbye. This one looks really good. Let me just skip to this one. Here what they did, they took 2/3 and they flipped it upside down. That's a thing. We call that the reciprocal. And I don't remember if we've studied that yet, but it's not the ratio. This is the one that looks good because we can say, oh, 2 times 2 is 4, 3 times 2 is 6. So this is the one that forms a proportion. Remember that another way to think about proportions is equivalent fractions. Well, I think we've used this word before. It just means it's a fancy word of equal, right? Okay. Write this proportion with digits. Okay, so in the book, John's giving us a big fat word sentence, and we have to translate it to numbers and symbols. 4 is to 6 as 6 is to 9. I'm going to write it out. You don't have to do this. 4 is to 6 as 6 is to 9. This sounds really hard, but it's so easy. 4 is to 6 as, that's the equal sign, as 6 is to 9. Make sense? And this, oh, okay, let's look at this. How do we get from 4 to 6? Okay, what if we think of this as 2 times 2, and then we multiply it times 3, right? 2 times 2 is 4, 2 times 2 times 3. Oh no, this is 2 times 3. So if this is 2 times 3, then this would be 3 times 3. That might be confusing to you. But I can see a pattern in these numbers. What I can do This is what our sentence was. Okay, I can take this down another one and make it 2 over 3, right? That is the simplest proportion. Then I multiplied it by 2 to get this, and then I multiplied it by 3 to get that. So here's 3. I multiplied it by 2 to get that, and then I multiplied it by 3 to get that. So by making one of the proportions smaller, we might be able to see more clearly the relationship between the two. Don't let my words confuse you on this. The main thing here is just to understand how we went from words to numbers. I'm making it harder than it needs to be. How do you feel about it? Thanks a lot, right? We just have one more example in lesson 101. Find the missing term in this proportion. And again, it gives us words. 2 is to 6 as, remember, as what number, and I'm just going to use WN for what number, is 230. Okay, so now we've been given some information about a proportion, but we have to fill in the missing piece. And this is just like adjusting fractions, you guys. 2 times 6, this is how you can think of it. We're going to multiply it by some number, top and bottom. We have to get 30 on the bottom, so we go, okay, 6 times 5 equals 30. 5 on the bottom means we have to do 5 on the top, because this has to be equal to 1. 2 times 5 is 10. And so we say, oh yeah, 2 6 is equal to 1030, so 10 is the missing number in our proportion, and that's our answer. Yay! Okay, if you think of this as just an exercise in either reducing fractions or changing them to make matching denominators, it's the very same thing. We're just setting two fractions equal to each other and calling them proportions. Okay, that is lesson 101. I'm looking at the homework. It's exactly like the problem we just did. Let me show you. Here's one, which ratio forms a proportion with 5 over 2? So you look at these and look for the one that matches nicely, where you can see the same number either dividing or multiplying top and bottom. Write this proportion with digits. 6 is to 8 as 9 is to 12. Remember, as means equals. 6 over 8 equals 9 over 12. Complete this proportion. 4 is to 3 as 12 is to what number? So, okay, it's going to be 4 over 3 equals 12 over what number? So you have to multiply. This is an improper fraction. That doesn't change anything. Improper fractions don't make anything different in these exercises. And then here's another, complete this proportion. 6 is to 9 as what number is to 36? So in this one, the mystery is on the bottom. In this one, the mystery is on the top. Don't let that confuse you. That's fine. Okay, lesson 101. Goodbye.